The sharing of electrical expertise is a valuable asset to the industry. Online forums provide a platform for individuals to learn, discuss, and exchange knowledge related to electrical practices, codes, and technologies. The benefits of these platforms include access to a diverse range of perspectives, the ability to ask questions and receive answers from experienced professionals, and the opportunity to stay up to date on the latest industry developments. Contributions from electricians of all levels of experience are crucial for fostering a collaborative learning environment. The knowledge gained from hands-on experience combined with theoretical understanding is essential for success in the electrical field. Staying informed about electrical codes such as the National Electrical Code is essential for safe and compliant installations. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and provides comprehensive guidelines for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect changes in technology and best practices. Familiarity with the NEC is essential for all electricians, electrical contractors, and electrical inspectors. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. Some key articles in the NEC include Article 210, which covers branch circuits, Article 220, which covers feeder and service calculations, Article 250, which covers grounding and bonding, and Article 300, which covers wiring methods. Understanding these articles is crucial for designing and installing safe and compliant electrical systems. The NEC also includes tables that provide information on conductor ampacity, conduit fill, and other important factors. These tables are essential for selecting the correct materials and ensuring that electrical systems are properly sized. For example, Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table is used to determine the maximum current that a conductor can carry safely based on its size, insulation type, and ambient temperature. The NEC also addresses the installation of specific types of equipment, such as transformers, generators, and motors. It includes requirements for overcurrent protection, grounding, and ventilation to ensure that these devices operate safely and reliably. The NEC also covers special occupancies, such as hazardous locations, healthcare facilities, and places of assembly. These occupancies have unique electrical requirements due to the increased risk of fire or electric shock. Staying up to date with the latest edition of the NEC is essential for all electrical professionals. Changes to the code can impact the design, installation, and inspection of electrical systems. There are many resources available to help electricians stay current with the NEC, including training courses, seminars, and online resources. Proper grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices to trip and de-energize the circuit. Bonding connects all metal parts of an electrical system together to create a low-impedance path for fault current. The NEC requires that all electrical systems be properly grounded and bonded to minimize the risk of electric shock and fire. Grounding electrodes, such as ground rods and ground plates, are used to connect the electrical system to the earth. The size and type of grounding electrode required depends on the size of the service and the soil conditions. Grounding conductors are used to connect the grounding electrode to the service equipment. Bonding jumpers are used to connect metal parts of the electrical system together, such as metal conduits, metal enclosures, and equipment grounding terminals. The NEC provides detailed requirements for grounding and bonding in Article 250. This article covers the size and type of grounding conductors, the installation of grounding electrodes, and the bonding of metal parts. Proper grounding and bonding can prevent electric shock, minimize the risk of fire, and protect sensitive electronic equipment from damage. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protective devices such as circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level. This protects the wiring and equipment from overheating and potentially causing a fire. Circuit breakers are resettable devices that trip when an overcurrent condition is detected. Fuses are one-time devices that melt and interrupt the flow of current when an overcurrent condition occurs. The NEC requires that all electrical circuits be protected by overcurrent protective devices that are properly sized for the circuit. The size of the overcurrent protective device is determined by the ampacity of the conductors and the rating of the equipment. The NEC also requires that overcurrent protective devices be readily accessible and protected from physical damage. Proper overcurrent protection can prevent fires, protect equipment from damage, and minimize the risk of electric shock. Wiring methods are the different ways that electrical conductors can be installed. The NEC specifies the approved wiring methods for different types of occupancies and applications. Some common wiring methods include non-metallic sheath cable or NM cable, metallic conduit, or EMT or rigid in cable tray. NM cable is a flexible wiring method that is commonly used in residential buildings. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Metallic conduit is a rigid wiring method that is used in commercial and industrial buildings. It provides excellent protection for conductors from physical damage and moisture. Cable tray is a support system for cables that is used in industrial and commercial buildings. It allows for easy installation and maintenance of large numbers of cables. The NEC provides detailed requirements for wiring methods in Chapter 3. This chapter covers the types of conductors that can be used, the methods of installation, and the requirements for supporting and protecting the wiring. Proper wiring methods can ensure the safety and reliability of electrical systems. Electrical calculations are essential for designing and installing safe and efficient electrical systems. Electrical calculations are used to determine the size of conductors, the rating of overcurrent protective devices, and the voltage drop in circuits. Some common electrical calculations include calculating the ampacity of conductors, calculating the voltage drop in circuits, and calculating the size of service entrance conductors. The NEC provides tables and formulas that can be used to perform electrical calculations. It is important to understand the principles behind electrical calculations in order to ensure that electrical systems are properly sized and installed. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of electrical systems. The NEC recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance of the conductor. Proper electrical calculations can minimize voltage drop and ensure that electrical systems operate efficiently. Electrical safety is paramount in all aspects of electrical work. Electricians must be aware of the hazards associated with electricity and must take precautions to protect themselves and others from harm. Some common electrical hazards include electric shock, arc flash, and arc blast. Electric shock occurs when a person comes into contact with a live electrical conductor. Electric shock can cause burns, muscle contractions, and even death. Arc flash is a dangerous condition that occurs when a short circuit creates a high-temperature arc of electricity. Arc flash can cause severe burns, blindness, and even death. Arc blast is the pressure wave that is created by an arc flash. Arc blast can cause injuries such as broken bones, lung damage, and hearing loss. Electricians must wear appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing to protect themselves from electrical hazards. They must also follow safe work practices such as de-energizing circuits before working on them, using lockout-tagout procedures, and maintaining a safe distance from energized equipment. Continuous learning and professional development are essential for electricians to stay current with the latest technologies, codes, and safety practices. The electrical industry is constantly evolving, and electricians must be able to adapt to new challenges and opportunities. There are many resources available to help electricians continue their education, including training courses, seminars, online resources, and professional organizations. By staying informed and up to date, electricians can provide their customers with the best possible service and ensure the safety of electrical systems. The sharing of knowledge and experience within the electrical community is invaluable. Experienced electricians can mentor younger electricians and share their expertise. This helps to ensure that the next generation of electricians is well trained and prepared to meet the challenges of the industry. Online forums and other platforms provide a valuable way for electricians to connect with each other and share information. By working together, electricians can continue to improve the safety and reliability of electrical systems and advance the electrical industry.